Good evening, guys. Once again we are here at the platform of YouTube with a video of 12th class chapter solution unit 1. And before we start this chapter, we will just introduce that what is solution and why we are read this chapter, what is the importance of this chapter, how many marks of the questions will come in the CBSE board from this chapter, what is according to the blueprint, how many marks of this chapter. Okay, so here before we start this chapter, as we know, we will discuss already this chapter in 9th class also. We will discuss the same topic like the solution. And what is solution? We all of the know that the solution is the mixture of homogeneous mixture in which two components are present, solute and solvent. Basically, we will discuss the binary solution in this chapter according to the 12th class syllabus. Now the question is arise, what is solute? Because we already discussed all of these things in our previous classes, in our junior classes, in 9th class. So now the question is that what is solute? Can anyone give the answer? What is solute? Yes? Okay. So the solute is, we can say that the component of the solution which is present in lowest amount, that is known as solute. And what is solvent? Obviously the component of the solution which is present in the major amount, higher amount, that is known as solvent. So solution is a mixture of solute and solvent, and it should be homogeneous, it will be heterogeneous. But here in this chapter we will discuss the homogeneous mixture. Now the second question, because already we discussed all the topics, these all questions is related to your previous classes. You will discuss in 9th class the second chapter, matter around us. Okay, so how many types of solution? In how many types we can classify the solution? Anyone? Okay, so this is the 3 types. Basically we can classify the solution 3 types. One is ideal solution, colloidal solution and suspension solution. This classification based on the particle size, solubility and the temperature effect, all of these things is depending on this. Okay, this classification basically depends on the particle size. If the particle size is less than 1 nanometer, then we can discuss that our solution is a ideal solution. And if the particle size is more than 1 nanometer, in between 1 nanometer to the 1000 nanometer, then the solution is discussed to be colloidal solution. But in 9th class NCERT we were discussed that it is mentioned that if the particle size is in between 1 nanometer to 100 nanometer, then the solution is discussed to the colloidal solution. But here in 12th class NCERT the same thing. If you discuss the colloidal solution, the size of the particle should be 1 nanometer to the 1000 nanometer. And the suspension solution, the basic example of the suspension solution, anyone can give the example of suspension solution? Solution of chalk powder in water. Ideal solution, solution of sugar in water, sugar and salt in water. And now the question is, what is concentration? Because all the solution is depend on the concentration. Whenever you are going in the laboratory, you can see the so many bottles at which the written is dilute and the concentrate. So what is the meaning of this dilute and what is the meaning of this concentrate? What do you understand by concentration? Let me know please. Number of solute or the amount of solute present in 1 liter of solution. Yeah, we can say that the how much solute is present in 1 liter of solution, that is known as concentration. Now what is solubility? Because in this is the main term, what is solubility. Actually whenever we are dissolving something in the solvent, whenever we are dissolving the solute in the solvent, the solute molecules take the space between the solvent molecules, and this is known as solubility. There are so many factors which is affected the solubility, but the main thing is the temperature. Can anyone give any example? Can anyone explain how the temperature will affect the solubility? Yes? Obviously students, solubility can be affected by majorly by the temperature, because the temperature is the term which can increase the kinetic energy of the molecules, and by which the molecules movement will be increased. As we are adding the solute into the solvent and we increase the temperature, obviously the space between the solvent molecules will be increases by increasing the kinetic energy, so the rate of the dissolution, rate of the solubility will be increases. Now the question is, how many types of the solubility? This thing we were not discussed in our previous classes. So we will discuss all the things in this chapter solution. Now why we are taking this chapter solution in the 12th class also, if we are read already in the 9th class? Because there are so many things which we were not discussed in the 9th class, like how many factors, and what is the solubility of the gases, how we can explain the solubility of the gases, how we can explain the solubility of non-volatile solid in the liquid, what is vapor pressure, how if we add the non-volatile solute into the liquid, how the solubility will be affected. There are so many examples of the daily life which we can discuss, like whenever we are cooking something in the pressure cooker, or whenever we are boiling something in a container, we are adding a 1 tablespoon of the sodium chloride into the water, and it will be decrease the boiling temperature, it will be increase the vapor pressure, and it will be decrease the boiling temperature. The thing will be boiled sooner. Now what is the reason behind this? How we can connect it, how we can explain at the basis of the solubility, how we can explain on the basis of how we can explain the lowering of vapor pressure with the help of the solubility, which we this one we discuss in this chapter. Same, the another example, you all can see the matka kulfi, and in this matka kulfi, to cool the substance and to make the longer freezing, to increase the freezing point, the person mix the sodium chloride or the salt, rock salt, with the ice cubes. Now what is the reason behind this? Why he mixed the sodium chloride, and what is the reason behind this? It will depress the freezing point. Now how it will depress the freezing point, we will discuss in this chapter. And another examples, osmotic pressure. Sea water is a salty water. For the purification of the sea water, we can use the osmotic, reverse osmosis. And what is the principle is this, why we are using this, so we can explain in this chapter. Scuba divers, another example, scuba divers use the mixture of the gases. They are not using the purely oxygen gases. Whenever they are going the depth in the sea, they are using the mixture of the gases, oxygen, nitrogen and the helium. Why they are using the mixture of the gases? Why they are not using only the oxygen? So we can explain this thing also in this chapter. Now we will discuss what are the content of this chapter. The next thing, different terms of concentrations. Okay, the first point, the first content of this chapter is the different terms of concentration, in which we discussed all the different terms like molality, mole fraction, normality, formality, and we were do the numeric questions of each of this thing. Types of solution system, liquid solution system, liquid solid, as we were as I told you that the solubility of the non-volatile solid in the liquid. Okay, and on the basis of this, and this will be explained by the Raoult's law. So we were discuss in detail that what is Raoult's law, and how the solubility of the how when we are adding the non-volatile solute into the solution, how it will be affected the solubility of the liquid. Now next thing is liquid and gas system. Liquid gas system can be explained by the Henry law. Liquid gas system, the basic example is the carbonated soft drink. We are using the Pepsi, Coke, and in all of this the carbon dioxide gas is dissolved. Same, the scuba divers, water treatment plant, how we can remove the impure gases from the water treatment during the water treatment. All of this thing is explained by the Henry law. And Next topic is the colligative property. This is most important topic of this chapter, because all of these, whenever the CBSE board making the questions, mostly the question is coming from this portion, the colligative property. One question is fixed from this portion. Always a 3 marks numerical will be come from the colligative property. You can see the last year sample papers, and you can see that the always one question is coming from the colligative property. There are 4 colligative properties, students, which we are going to discuss in this chapter. One is lowering in vapor pressure, another is elevation in boiling point, how the boiling point will be elevated, and depression freezing point, osmotic pressure, and last topic is abnormal molar mass. So these are the content which we are going to discuss in this chapter, and hope so we will enjoying, because this chapter is related to daily life. We will discuss all the examples which is connected to our daily life, which is connected to these chapters, and according to blueprint, this chapter is for the CBSE board. This is for the 4 marks chapter, and the mostly questions coming from the colligative property. One of the questions comes from the Henry Law's statements. Sometimes they will ask the Henry Law statements, and sometimes they will ask the MCQ based question from the Henry Law statements and Raoult's law. There are positive derivation, negative derivation. So whenever we will start this chapter, we will discuss in detail. Okay. So this is the introduction part which we completed now. Next, today we will discuss the something like Henry Law. Before we start the Henry Law, we will discuss the solubility. As I told you, solubility is how much solute dissolve in the solution, how much solute dissolve in the solvent while making the solution. And there are so many factors which affecting the rate of the dissolution. One is the ionic solute. If the solution is the ionic solute, then it will be dissociate easily. For example, if you are taking sodium chloride, and if you are taking wax or the paraffin or petrol, if you are adding the sodium chloride into the water, it will be dissolved easily. If you are adding the petrol into the water, it will not dissolve. It will not dissolve. Why? Because the sodium chloride dissociate into their ions. It's an ionic substance. It's an ionic solute. It will be dissociate into Na plus and Cl minus. While if we are taking the examples of petrol, it will not be dissociate. It's a non-polar solute. It will not dissociate into the water. So it will not be soluble. Liquid solute. There are 2 types of the liquid solute: miscible, immiscible. Again, we are taking the example miscible liquid, like if we are mix the water into alcohol, or if we are mix the alcohol into water, it will be dissolved properly, and it's make a miscible liquid. If we are taking the example of water and petrol or oil, there are 2 separate layer, 2 separate phase, that is called immiscible. And next is gas solute. So the gases solubility is mainly affected by temperature, pressure, and it will be explained by Henry Law. So now we are going to discuss the Henry Law of this chapter. What is Henry Law? In detail we will discuss the Henry Law. So basically we can say that the Henry Law is described the solubility of the gases in the liquid, and the solubility, according to the Henry Law, the solubility of the gases in liquid is directly proportional to their pressure. The directly proportional to the pressure applied by the gases on the surface of a liquid. If we can directly proportional, it means to say this is a relation of like a linear line relation. If you plot the graph between the solubility and the pressure, it shows the linear line, but for different gases should be different, because the different gases solubility is different, their particles space is different. Now what are the key components of Henry Law? Here you can see, as we know, the Henry Law describes the solubility of the gases in the liquid, and it is directly proportional, the mass of the gas which will dissolve in the liquid, it is directly proportional to the pressure applied by the gas. So one is the partial pressure. If we are taking the 2 gases, so partial pressure of gas 1 and partial pressure of gas 2. Then second is solubility of the gas. How much the solubility of the gas in that liquid? And the solubility of the gas in liquid is depend on the equilibrium constant, guys. What is the equilibrium constant? Okay, so the equilibrium constant, or we can say that the Henry constant, a constant at which the solubility of the gas, yani ki the gas which we are taking to soluble into the liquid, amount of that gas and amount of the solution, it comes at a equal side, means the forward reaction and the backward reaction comes at the equal. So that is that we call the equilibrium. At this point we can say that the equilibrium constant will become. So these are the key component of the Henry laws. Now after this key component, we will discuss that what is the Henry equation, how we can write the Henry equation, how we can represent it. So the concentration of the dissolving gas is the C, guys, and it is directly proportional to the pressure, like how much concentration of the gas is dissolved in the liquid, that is depend on the gas, how much pressure that gas will be applied on that the solution surface. So C is directly proportional to P. Whenever we will replace the proportion sign, there will be a constant come, that is K. This is called Henry law proportional constant, specific to solvent, solute and temperature. It will depend on the solute, solvent and temperature. The main one question will be comes from this portion, because always a one question is comes like what is the order of the solubility of the gases. या आपके सामने कोई भी एक क्वेश्चन ऐसे दे दिया जाएगा कि like है ना, these are the gases, which gas is more soluble in the liquid. So this is depend on the Henry constant. If the value of the Henry constant is low, then the solubility of the gases will be high. There is a table which is given in the NCERT. You can see that table, and in that table the Henry law constant value is given. Applications of the Henry law. Henry law is most applicable in daily life. We can connect more examples, so many examples, as we can discuss the carbonated drinks. We all are using Pepsi, Cokes, and in which the carbon dioxide gas is dissolved. So how much carbon dioxide gas we have to dissolve, that will be depends on the Henry law. Scuba diving, as we were discussed, the scuba divers, whenever they are going to depth sea, they are using the mixture of the oxygen, nitrogen and helium. Why they are using the mixture? Why they are not using only the oxygen? Because whenever they are going in the depth, the pressure, atmospheric pressure will be, the pressure will be increases. As the pressure will be increases, the dissolution of the oxygen in our body blood will be increases, because our body is taking equilibrium with the atmospheric pressure. As the pressure of the sea, whenever they are going in the depth of the sea, the pressure will be increases. So the body pressure, the dissolution rate of the oxygen in the blood will be also increases. As they come at the surface, the pressure will be, atmospheric pressure will be low, but the pressure of the blood will not be comes at that situation, मतलब like वो एकदम से directly atmospheric pressure के बराबर नहीं आ पाएगा. In that conditions, there will be bubbles will be arise, and if the bubbles goes to the heart, the chances of the heart attack. So why we are taking the mixture of the nitrogen and helium? Because the nitrogen and helium are the inert gases. They will be decrease the dissolution rate of the oxygen in the blood. Whenever they are going into depth, as the pressure, atmospheric pressure will be increases, the rate of the dissolution of the oxygen will be increases in the water. So this rate is decreased by the nitrogen and the helium gas, which will be mixed in the gas cylinder. That's why they are using the mixture. Atmospheric gases exchange, we all know that we exchange the oxygen, we exchange our body from carbon dioxide with the oxygen to the atmosphere, and this exchange is happened by the lungs, and this exchange is also the example, most valuable examples of the Henry law, because you know that the oxygen is dissolved into the blood and the carbon dioxide is also dissolved into the blood. So the solubility of the carbon dioxide, make a substance, make a complex with the blood, that is called carboxyhemoglobin, and the oxygen make a complex with the hemoglobin, that is known as oxyhemoglobin. So it will be dissociated and carbon dioxide will be released and the oxygen will be dissolved into the blood. So this is also the examples of the Henry law. Now the water treatment, there are so many impure gases like the sulfur dioxide, nitrogen dioxide. This is present in the water, wastewater, and which increase the smell in the water. So during the treatment, these gases will be removed from the water by applying the Henry law. Now there are some questions related to Henry laws. Okay, before this question we know that what is Henry law, as we were discussed. What is Henry law? Henry law is a law which is give the dissolubility of the gases, solubility of the gases into the liquid, and the solubility of the gases into the liquid is directly proportional to the pressure applied by the gas on the liquid surface. So according to Henry law, the solubility of a gas in a liquid is directly proportional to option 1, the temperature of the liquid, the pressure of the gas, the volume of the liquid, the concentration of the other solute in the liquid. So the temperature of the liquid तो हो नहीं सकता, because statement is that कि the solubility of the gases is directly proportional to the solubility of gases is directly proportional to the pressure applied by the gas. तो temperature तो गलत है. वॉल्यूम ऑफ द लिक्विड, वॉल्यूम की कहीं बात ही नहीं आ रही स्टेटमेंट में, ये भी रॉन्ग है. द कंसेंट्रेशन ऑफ द अदर सोल्यूट इन द लिक्विड, इट इज ऑल्सो रॉन्ग. नाउ द करेक्ट वन इज द प्रेशर ऑफ द गैस, बिकॉज इन स्टेटमेंट वी रीड दैट द प्रेशर डायरेक्टली प्रोपोर्शनल टू द प्रेशर ऑफ द गैस. सेकेंड क्वेश्चन, व्हाट डज हेनरीज लॉ डिस्क्राइब? द रिलेशन बिटवीन प्रेशर एंड वॉल्यूम ऑफ गैस, the relation between temperature and volume of gas, the relationship between solubility and pressure of gas, the relationship between solubility and temperature of gas. The first option is relationship between pressure and volume of gas. Volume कहीं भी statement में नहीं आ रहा. We are not going to discuss the volume of the gas. We are going to discuss the solubility of the gas into the liquid, and that will be directly proportional to the pressure. So first option is wrong. टेम्परेचर पे डिपेंड करता है, इट विल बी अफेक्टेड बाय टेम्परेचर, बट टेम्परेचर इज नॉट कनेक्टेड टू द वॉल्यूम ऑफ गैस इन दिस स्टेटमेंट, which is also wrong. The relationship between solubility and the pressure of gas, it is correct option, because we know that it gives the solubility of the gas and it is affected by pressure. So question number 1, option C, option B is right, the pressure of the gas. And the question number 2, again option B is right. Which of the following factor affect solubility of gas in liquid according to Henry's law? Which of the following factor affects solubility of gas in liquid according to Henry's law? Surface area of liquid, types of gas, pH of liquid, partial pressure of gas. As we know, as we increase the pressure of the gas applied by the gas, the dissolution, the solubility rate of the gas will be increases. So obviously the correct option is D. Next question, Henry law commonly used to describe the solubility of gas in. So the Henry law is given by the solubility of the liquid and gaseous system. So here the option is mentioned A, solid. Wrong option, solid कहीं आ ही नहीं रहा है. The option B is liquids. Okay, liquid नहीं देगा, क्योंकि liquid हम राउल्ट्स लॉ में पढ़ेंगे. Gases and liquid. Okay, इसको अभी हम रखते हैं. D ऑप्शन देखते हैं पहले, प्लाज्मा. प्लाज्मा का कहीं पर भी यहाँ कंसेप्ट आया ही नहीं है. वी आर डिस्कसिंग द लिक्विड सिस्टम, सॉलिड सिस्टम एंड गैसेस सिस्टम. So the correct option is C. Okay, next question is, which of the following gases would be expected to have the highest solubility in a liquid according to Henry's law? So I told you there is a table in the NCERT, and this is the table in which the given value of the Henry constant, and you can make a answer of this question on the basis of that table. If the value of the Henry constant will be low, then the solubility of the gases will be high. If the value of the Henry constant will be high, then the solubility of the gas will be low in the liquid. So you have to learn, you have to like a idea of that table. आपको learn करने की जरूरत नहीं है. You just take a like a idea of this table, that what is the order of the gases. There are so many order of the gases in given that table. So you just take a idea. So ऑक्सीजन की अगर हम बात करें तो ऑक्सीजन के लिए हेनरी कांस्टेंट ज़्यादा होता है. नाइट्रोजन के लिए ऑक्सीजन से भी ज़्यादा है. कार्बन डाइऑक्साइड अभी इसको रखते हैं हम, हीलियम के लिए भी ज़्यादा है. तो इन चार ऑप्शन में से सबसे कम हेनरी कांस्टेंट है कार्बन डाइऑक्साइड का, तो ऑब्वियस सी बात है कि सॉल्युबिलिटी भी कार्बन डाइऑक्साइड की ज़्यादा होगी। अच्छा, यहाँ सबसे ज़्यादा क्वेश्चन जो है वो हेनरी लॉ में एक तो ऑर्डर पे ही बनते हैं, व्हाट आर द ऑर्डर ऑफ द सॉल्युबिलिटी ऑफ द गैसेस। So you can give the answer of this order on the basis of the solubility, on the basis of the Henry constant value, and that value is given in the table in the NCERT book. So you just see that table and take an idea that what are the values of the Henry constant and how you can make a order of these gases and the solubility. Take take a confirmation that which gas will be more dissolved. Okay. So these are the 5 questions which we were discussed in this topic. Hope you enjoy, guys. Again, thank you so much, and share this video with all your friends. So hope it will be helpful for the others also. Thank you, guys. Thank you so much. Bye.